Okay, folks. Next presentation, we have Maja Kohek. Just to introduce her. Maja holds a bachelor's degree in social anthropology. And she's working in the field of drug use and drug policy. In the past, she has worked with non-profits in Slovenia, the Balkans, and other countries in the field of cannabis. She's co-authored several papers, newspaper articles, translations, and had presentations on a national and international level. Although her past work has focused on cannabis, her true passion lies in the research of psychedelics in therapeutic and social contexts. In 2016, she therefore started collaborating with ICEAS, the International Centre for Ethnobotanical Education, Research and Services, in Spain, where she was part of the research group investigating the acute subjective effects of Ibogaine. Can we be a bit quiet over there, please? Sorry. Thank you very much. Thank you. Maja.
Thank you. First, Dana, is he still here? No, gone. Well, thanks to Dana, big thanks to Dana that he brought us together again. I'm going to present a study about acute subjective effects of Ibogaine. Some of you have already heard it in Vienna, but there is some new stuff in it too. So we interviewed 20 people who took Ibogaine and asked them to describe the experience. So if Dana was talking about more pharmacological effects of Ibogaine, I'm going to talk a little bit lighter topics now about what happened to people. So scroll down just briefly on the dosage. Yeah, well, it doesn't work like. Go. There we go. Well, if somebody is interested in the dosage, the people took different kind of combinations, either only hydrochloride, total alkaloid, combination of the two, root bark with total alkaloid, so and all of these were flat doses. So if we move to the next one. So what we come up with, this one, is this, let's call it map. And as you can see, there is a lot going on during an Ibogaine experience. And we divided the acute effects into 8 categories and 10 subcategories. But that doesn't mean that people experience all of these effects. It's more a combination of some or many of them. Among the physical effects are the most prominent vibration throughout the body, feeling heavy, a suppression of appetite, dizziness, impaired motor control. Some people felt dehydrated, but more because of the inability to move and drink. Similarly was also urinary retention, and any sort of movement would cause heavy nausea and vomiting. Less than half individuals would experience slowing down or speeding up the heart rate, which was usually a consequence of the internal experience. Some experience digestive difficulties like feeling gassy and constipation. Few of them had tremors, and some of them would experience an aphrodisiac effect, but that would be at the end of the experience and usually because of not taking opioids. Then visual effects we divided into open eyes and closed eyes visuals. And then closed eye visuals into 3 subcategories, so ancestors and entities. People would have visions about that. Sceneries and landscapes, so that could be also in different continents, future scenarios. Then horrific scenarios would be like apocalyptic scenes, just darkness or feeling alone, mistreatments, destruction of the planet, violent behaviors, or very traumatic personal content. Then auditory effects would be enhanced sensitivity to the sound. Distortions like a buzzing sound or sound of waves would be very prominent. In few cases, people would hear chanting that could also remain throughout the whole experience, not only on the beginning. Sensory effects, like all the other senses, touch, sight, smell, would be very sensitive. Less commonly, people would experience synesthesia more in the sense of feeling the sound, or the music would become animated. Among the cognitive effects would be wakefulness, increased appreciation of things, memory enhancement, a deep understanding of everything, enhanced conceptual thinking, introspection. Time perception would get distorted in most cases. Another one among the cognitive effects would be self-psychoanalysis enhancement. So people would experience like a reactive process or resolution of personal issues. They would refer to it as an accelerated psychoanalytical treatment. Another quality was the observer quality, which means that people would feel somehow distant to the visions that they saw, so not really emotionally entangled in it, more like in a state of witnessing. Catharsis, which would have an effect like a cleansing effect, a sensation of rebalancing, mental clearness, rejuvenation. Ego dissolution was a prominent one as well, experiencing death and rebirth. Most of them experienced empathy, love, pro-social behavior, so in the sense of decrease in judgmental thinking, increase in empathy for other people, feeling reconnected with other people. Among spiritual states, feeling interconnected, understanding spiritual roots, the source of life or the life's purpose. They would all agree that it feels like becoming almost like a new person, or at least a better person. And of course, in more than half of our study subjects had issues with dependencies. So all of them experienced reduced craving. Most of them wouldn't have withdrawal symptoms. They would, the visions would show the triggers for the drug abuse, how it developed. There would be a lot of symbolism in their visions, which could be sacred or profane. And they would say that it created some kind of breathing space. It gave them time to assess things. It gave them an opportunity to choose. Among adverse effects, there were not many. One person reported arrhythmia and seizures and had to be taken to the hospital. But again, that was probably because of a combination of things, because of alcohol and other drug use just before the treatment, because the setting where she took it was not really appropriate, because the dose was maybe even too high for her body weight, and so on. So it was a series of complications that led to it. And then after effects, people would say that even if the experience was very challenging, it was still worth it. They would feel very happy, joyful, self-aware for several days, even months after that. They would have a clear mind. The thoughts would come very naturally. They would gain a sense of taking care of themselves, about taking care of others, emotionally, physically, and spiritually. They would sleep better. The compulsiveness that they might experience would be gone. They would change eating habits, change relationships, workspaces, lifestyle in general. So most of them, although, agreed that to remain in this kind of state, one has to also do some after work. Maybe some psychotherapy, meditation or yoga, and stuff like that would help them to remain in this state of well-being. So, next one. A similar study was published just recently, this year, in a journal of psychedelic studies. What they did was basically the same thing, but only with people who took Ibogaine for treating drug dependence. And this study was done with 10 people. And next one. They identified a total of 13 teams, which they organized into 4 main categories. So category 1, neurological and physical effects, which would be subjective effects, subjective experience of localized brain activation, they call it, meaning that Ibogaine activates specific areas in the brain, and it's experienced as zapping or cleaning the neurons, which is something that also our study subjects would mention. Then physically draining experience, meaning feeling heavy, sore, wiped out, and impaired psychomotor coordination, dizziness, and or vomiting. Then category 2 was auditory and visual phenomena, which is buzzing and vibration sounds at the onset of experience, entering into specific settings. They would mention fields, womb, woods, outer space, abandoned mental institute, different scenarios. Cyclical organizational imagery in visions, so repetitive messages that they would gain, which is also a thing that some of our study subjects mentioned. Then mix of dark or scary and joyful or peaceful imaginary. And the experience was difficult to describe. Category 3, they put alleviation of withdrawal and cravings, so nearly immediate and lasting attenuation of withdrawal symptoms, minimal to no craving during or after the experience. And category 4 was changed perspectives, so increased self-expectance, decreased self-critical thought patterns, which means they would experience self-love, depressions going away, the sense of taking care of oneself, and then more spiritual outlook, which means more connection to other people or to the universe in general. They would say that they are aware that they have to meditate more. That was quite common. And they think that Ibogaine would be effective in helping others. So both studies found that it's quite difficult for people to talk about the experience, but all in all the people agreed that it was a profound experience, which lasted way beyond the acute effects. And the categories and themes identified in both studies are very much alike. However, the difference in the study sample is that one was focusing on drug-dependent persons only. So that influences a bit the conclusions in the studies. And the most prominent effects of ibogaine identified in both studies were the anti-addictive properties and its influence of attenuating withdrawal symptoms and cravings. So let me read a couple of quotes from the people. Next one. So one of our study subjects said, "What the medicine did for me when I was in an addictive phase, it gave me breathing room. It gave me time to assess things. Whereas, you know, I've been falling down a pit for 20 years. And I'm someone that has gone through the 12 steps, and that's just, it helps people, and God bless the people that it helped. It did not help me, it did not help me twice. And more importantly, it just made me more pessimistic about my chances of ever being able to live a normal life." So next one would say, "It was just showing me how the reward system works in the brain. It just always wants a reward. It was showing me what the things were that hit my reward circuit more than others, and possibly why, if that makes sense. Giving me insights into why I keep performing these behaviors, specifically about the pot. I've been smoking pot for 20 years, off and on. It kind of reminded me of an incident that happened when I was a child that probably predetermined a course for a period of time. It brought up that in my mind again, how this manifests in the body pains for me." And another one from the recent study said, "The ibogaine experience was difficult, but after that it's been easy. I haven't had struggles, I haven't had cravings or drug dreams or really no obsessive thoughts. It's just been extremely easy, and the only thing I can attribute that to is ibogaine, for sure, because I've done this countless other times. On my own or with Suboxone, cold turkey, or going to rehab or outpatient, I tried everything. The only thing that I can attribute that to is ibogaine, for sure." So next, in our case, the interviewed people took ibogaine for different reasons, not necessarily for treating addiction. So among other prominent effects we found was the pro-social component of the experience, an effect of enhancing empathy and compassion. And here are some examples from what people told us. "A lot of it was based on relationships I've had with people. It showed me what I have done to hurt them, and what it did, it switched my role, it put me into their shoes and vice versa. The people I've hurt, in the visions, I would go and apologize to them and ask them to forgive me. And the people who'd hurt me, I forgave them. Basically, once I forgave people, everything changed. All that went to the side and the universe opened up." And the next one said, "I was moving through thoughts about one child and then my other child and my relationship with my parents, my relationship with my family and with my job. What I found was a real tenderness, like soft authenticity, and a level of compassion for myself and for people that I've been angry with or had some resentments towards. It just seemed as if those types of sharp, resentful feelings were just melting away." So the individuals in both studies would also develop personally. They would be self-reflective and gain important insights in their lives. And some of the examples would be, after the vision started to subside, after all the deities, spirit animals, totem, and ancestors gave me all of these messages, what resulted was a very long process of reflection and contemplation about my relationships and work relationships. I had different perspective now, with which I could digest my life. For 2 or 3 days, I just thought about my worldly life and saw how I could bring it into this new perspective of light that I have acquired. And another person said, in this new study, I'm going to be nicer to myself and not take any abuse. So, in conclusion, even if each person had a unique story to tell, they all agreed that the experience was far from pleasant, but in the end it made them feel more joyous, happy and hopeful for the future. So where do we go from here? In ICERS, we are currently working on the development of a questionnaire to assess the acute subjective effects. Soon we will have it ready for application. So I would like to use this opportunity to invite you to participate in the upcoming study. Especially those of you who are treating people with Ibogaine. Please get in contact with us. Give us your contact information so we can get in touch with you when we have it ready and we can start the study. Well, that's it. Thank you for your attention.
Where did Maja go? Any questions for Maja? Because it's going to take us a couple of minutes to switch things around. We have a Zoom next. Does anyone have any questions?
Could you maybe just elaborate on what you need from providers to help you with?
For now, contact us that you would be interested to participate. We are still working on the questionnaire. It will take us a short while, but then when we have it ready, we would need the access to your to the persons who you give treatment to fill out the questionnaire, basically. That would be.
You ask for access and you're wanting to communicate directly with them, or you want us to deal with the questionnaire?
Well, that can be discussed with providers. I mean, maybe in some cases it would be better if it goes through the provider. In some cases, maybe we can access directly, but we can discuss that one-to-one. Thanks.
The primary diagnostic tool we used before treatment was the corneal medical index. I don't know if you employ that in your protocol, but the corneal medical index, they have one for men and one for women.
Uh-huh.
It's a detailed yes and no, 285 questions
Uh-huh.
about the person's entire physiology.
Uh-huh.
Starting from the head and going around the body. It's a very good diagnostic tool. And in conjunction with the corneal medical index, we always administer the addiction severity index, the
Uh-huh.
ASI, which should be included in all protocol for screening patients, because the ASI gives you a good capsule of what's going on with the patient.
Okay, thank you for that. We'll take it into consideration.
Anyone else? Okay, thank you. We're just going to take a couple more minutes just to set up the Zoom. Thanks.
Who's next?
Justin Kirkland.
Let's see. Can you hear me at all?
Okay, yeah, we can hear you. Can you hear us?
Okay. Yeah, no problem.
Okay, let me just introduce you, Justin. So Justin Kirkland is a chemist with experience in natural products, drug synthesis, and drug formulations for improved bioavailability. He's earned a BS in agronomy and an MS in biology. He was recently awarded a US patent for the improved synthesis of the ergoline BOL 148, useful for treating cluster headaches. He's currently enrolled in medical school in Belize at the Central American Health Services University. Justin.
All right, so I might need some help here to share the screen. Let's see. So I have the presentation ready. How do I get the PowerPoint onto your screen?
There should be a share button. Share
Let's
screen.
see. I don't know if you have to initiate that or.
If your PowerPoint's open, then you can just, I don't know where it is in Zoom on the desktop, but there is a share screen and it will just flip over to the PowerPoint.
Stop video, pin video. Yeah, I can't find anything.
There should be a share screen icon.
Yeah. Oh, there we go.
Okay.
Got it. How's that?
Good.
All right. So I'll give you a quick background on my involvement with Ibogaine. As Jeremy said, I'm a chemist. I spent 2 years from 2005 through 2007 in Baja, Mexico, working at a maquiladora as a chemist, primarily synthesizing antioxidants. And I attended a small Ibogaine meeting after Howard Lotsoff and Bob Cisco contacted me because of our manufacturing location in Mexico. So I went up to meet them in San Francisco, and I ended up meeting Claire Wilkins, who had a clinic, turns out, about a mile from where I lived. And so I was familiar with Ibogaine through the literature, but never had seen it in action. So Claire invited me up to her clinic to meet some patients that were having treatments, and I was incredibly impressed, and ended up doing a little bit of analytical chemistry on her Ibogaine supply, looking at some of the minor constituents and overall purity. Around 2007, the violence in Mexico escalated, and I ended up returning to the U.S., working at another chemical plant, but still really excited about the positive benefits I had observed while living in Mexico. So I ended up contacting Albany Medical College, Stanley Glick specifically, and the chemical plant I worked at in Illinois. We ended up licensing the patent and manufacturing rights to 18-MC, or 18-methoxychloronaridine, that was in Dana's presentation just a little bit ago. So we had a team of PhD chemists work on the synthesis of 18-MC, trying to optimize it with an eye on commercialization. With that in mind, Dana asked me to speak today about some of the synthetic routes to some of these compounds, and the eye on the goal of the presentation is to look at probably more plant preservation. As Dana discussed, sometimes there's over harvesting in Cameroon of the Tabernanthia iboga, and we felt like chemical manufacturing might give an alternative to for more of a sustainable plant growth. So here's our favorite plant and the topic of the conference in the top left here, in fruit, Tabernanthia iboga, the iboga plant. To the right, the larger picture is greenhouse grown iboga plant up in British Columbia. And then on the bottom left, there's myself with Dennis McKenna, the ethnobotanist. Dennis and I have been corresponding about iboga for a few years now, and he's actually getting ready to move up to British Columbia here, in, maybe even in the next week. And I mention this because in British Columbia, as you can see in these slides, at a university, they've started tissue culturing Tabernanthia iboga. So there's a petri dish with growth media there on the top left, and it turns out that the iboga plant is quite amicable to tissue culturing. You can see it's transferred there to the right, the top right, the seedlings again in an agar nutritional media in a sterile environment. There on the bottom left is a more of a mature plant, and then the bottom right would be the isolated roots and growth media. And so the alkaloid content in the plant is the highest in the root bark, and so the goal would be for root growth. So beyond tissue culturing, something that we've discussed and looked at the technology, which is well published in other plants, is called hairy root technology. And so I've got a little example of a flow chart here on the left side where an agrobacterium is inoculated into a plant, and the agrobacterium actually inserts some of its genes into the plant's genes. This happens in nature. In some sense, it's becomes a transgenomic plant. But like I said, it occurs in nature anyways. What you see from this type of infection is that the chemical content of plants seem to jump up tremendously, if not exponentially. And so you'll get the expectation is that you would get a much higher rate of alkaloid production in a laboratory environment. On the right, you see an example of a bioreactor with isolated roots growing for chemical production. So the expectation is that with some research on Tabernanthia iboga and this hairy root science, that you could set up bioreactors of simply just the root portion of the plant for alkaloid production. This is being commercially done. Here's an example on a slide of other plants that are being used in this type of science and the type of chemicals that they're producing. So this isn't, I mean, this is being commercially done right now. As far as we know, it's never been applied to ibogaine series of plants. And so Dennis is up there, or headed up there with the goal of looking into this. And if anyone's interested in certainly pursuing it further, supporting him, be glad to put you in touch with him. It's a really exciting area of science that they hope to pursue. My background, however, is probably a little more in depth on the chemical side. So I thought I would take a look at what types of compounds exist in nature and what type of compounds could potentially be made and how they could be made. So here you see the chemical skeleton with substitutions for either ibogaine or 18MC. Some stuff you'd seen probably previously in Dana's presentation a little earlier. So for ibogaine production, there are methods that have been used and technology available, both published on the internet, using the alkaloids from the plant Vocanga africana. So here on the right, you see the alkaloid vocangine, and the semi-synthesis of ibogaine is accomplished from vocangine by elimination of that carbomethoxy group you see towards the bottom of the molecule, about 6 o'clock on this image. And so this has been commercially done in a GMP environment, isolation of the vocangine from Vocanga africana, and then the elimination step. So it's totally scalable. Well, Conga africana is certainly more plentiful plant supply-wise than Tabernanthe iboga, so it's certainly a valid and possible route for manufacturing of ibogaine, and probably also amicable to the hairy root technology that I showed a couple slides ago. This is a study done on Tabernet Montana hystrix. Here towards the bottom, you can see all the different types of alkaloid compounds with similar structures to ibogaine. I've listed some of them over here on the right, including ibogamine. But what you can see is that there's all types of areas of substitution for analogs and congeners of ibogaine that do exist in nature and could also exist from a chemical manufacturing standpoint. You can see substitutions that are possible on the indole ring. On the top left of these, the chemical structure image, the indole ring is the numbers 9 through 17 going counterclockwise to the left. In the case of ibogaine, you'll see a methoxy in the 12 position, which is also the 5 position on just the indole ring itself. So in nature, there's a lot of these compounds available and a lot of derivatives. So I certainly enjoy chemistry, but oftentimes Mother Nature does a much better job at chemical manufacturing than we do in the lab. And because we're interested in these compounds doesn't mean we have to go into a chemical lab necessarily to obtain them. So probably these compounds are all identified and isolated by chromatography. This study specifically, I think, used NMR for identification. It was a group down out of Brazil. One of my strongest interests botanically right now is in the plant Tabernet Montana albiflora. I've been working with Dennis trying to source some of this material. I think this voucher specimen was from Suriname, and it has a really interesting compound called albifloramine, which you can see there on the right. In comparison to 18MC, this would be 18-hydroxychloronaridine. And my gut feeling is that this would likely have some anti-addictive properties in and of itself. But I also think, much like vocangine can go through an elimination step to become ibogaine, I would expect that albifloramine can have an addition step to add the carbon on the hydroxy to make 18-methoxychloronaridine or 18MC. So I would expect a few things. That this alkaloid itself probably has the possibility of having anti-addictive properties. And I also think it could be used in the semi-synthesis of 18MC. So when I was previously working on the synthesis of 18MC, it was about a 24-step synthesis. So it was a really long and laborious process. So finding a botanical source and eliminating that down to one step would certainly have major benefits. So at the moment, we're looking to obtain some plant material and validate the presence of the alkaloid and see what opportunities it may present. On the chemistry side, here on the top left, you can see that in 1966 was the first published total synthesis of iboga alkaloids done at MIT. 18MC, you can see some 18MC synthesis and congeners done in 2002 with Kuna and Glick. Dr. Glick is at Albany Medical College, who has the patent holder jointly with the University of Vermont on 18MC. Martin Kuna has since passed away since we licensed 18MC, but he was the chemist that had the laboratory that was making 18MC and derivatives. During my research for this presentation, I found this other document here on the right side from the 70s. I thought it was quite interesting. It's a CIA memo between the Department of Defense and a chemical contractor that's unnamed. This is part of some of the MK series of research that the CIA did. The most famous one, of course, being MK Ultra. You can see in the last paragraph, moving on to page 7 at the very bottom of my slide, that the contractor had suggested they wanted to start looking at analogs of ibogaine as part of their mind control and behavior modification process. So it looks like as early as 1970, other analogs of Ibogaine were synthetically, potentially a library of them developed by a contractor under a federal government grant. So this is typically what the chemistry of Ibogaine and 18MC looks like. A lot of chemical structures. Typically, in the literature, you'll see what's considered a convergent synthesis. If you look at compound number 30 there towards the bottom left side, the indole structure or tryptamine with the 7-membered ring to the right, you'll see a lot of synthesis of that compound. In the case of Ibogaine having the 5-methoxy, in this case, this is 18MC, so that's absent. And then you'll see this structure towards the, in steam 4, towards the top right, 37 and 38, adding that second ring system on. So this is a laborious and pretty common route towards chemical synthesis. In this case, totally done in solution phase. So that's your standard chemical manufacturing where you see large vats of fluid and stirring and heating. It's a very low yielding overall process and with a great deal of waste and obviously clearly a long amount of time and effort to produce a little bit of product. So what I've been working on the last 2 years is the solid phase synthesis of injectable peptide drugs. In this case, most of the drugs I were working on were peptides used for growth hormone releasing of the pituitary gland. And the reason I bring this up is peptide synthesis is also a very long and laborious process. The primary peptide I worked on had 43 amino acids and 1 fatty acid. And so that's 44 to 45 steps of chemistry. In my case, we repeated each step twice in order to make sure it went to completion with high yields. So that was 90 steps of chemistry. I would perform 90 chemical reactions to have my crude raw material. So peptide synthesis is typically quite different than normal chemical API synthesis. And in this case, the sphere you see on the top left is actually a physical ball put into a reaction vessel. It's a polystyrene ball that's been derivatized. And the reason that peptide synthesis is so interesting and highly efficient is that with solid phase synthesis, you're able to do a chemical reaction and then rinse your compound, and these physical polystyrene balls hold onto your drug, making all of your side products and reagents rinse away while keeping your drug literally not going through the filter. So in this case, the steps shown here are an amino acid, the PG in green being a protecting group. Coupling is actually done by adding a coupling reagent. And then you see the amino acid then attached to the nitrogen on the polystyrene bead. This is followed by a deprotection step. Again, some additional chemical reactions that eliminate the protecting group selectively. And then you're able to repeat the process with the next amino acid continuously. So peptide drugs are typically, or not typically, they're almost always long linear drugs that are series of amino acids. And during the manufacturing of all these drugs, I wondered if this type of technology could be applied to Ibogaine. So here's my lab on the left. It's a small hallway, so I was able to do a lot of work in a small space. The first tower you see there on the left is a preparatory HPLC. It's essentially some really expensive pumps that are pumping the API, the active pharmaceutical ingredient or compound, through an HPLC column, a prep column, in order to purify it. So we're basically eliminating by cuts each of our side products to make sure our drug is as pure as possible. There's a little white device just beyond that that's a robotic arm that's a fraction collector, so I can collect each portion of my reaction. The next gray, dark gray box you see is about the size of a refrigerator. There's a front view of that instrument there on the top right of this slide. This is my peptide synthesizer. And so the bottom half are reagent vessels in solution. So each peptide that I'm adding in series to the polystyrene beads is mixed ahead of time in those vials and then pumped towards the top into a reaction vessel. It's all air driven. We had nitrogen driving the fluid. And then we had the option of having heating, microwaves, and then some analytical work all done on the system. So this system is completely automated and computer controlled, which is what's of the greatest interest to me. So if a solid phase synthesis of ibogaine or 18-MC worked out, then as long as you have access commercially to either the reagents or the resins, anyone with any type of similar system could essentially run the same protocols via the computer to manufacture ibogaine on a smaller scale. So I really think this is an area of technology, if applied to ibogaine, has a lot of potential. Beyond that system is an LCMS. You can also see there in the bottom right. So we had analytical capability to test everything, make sure we were hitting our target compound at an appropriate purity. And then also in this small lab at the very end, facing the photographer is a hood with a rotary evaporator for removing solvent and removing fumes from any chemist operating on it. So my goal of sharing this slide is just to let you know that you can do really incredible, high-yielding, highly technical drug manufacturing in a small space with a really small overall economic investment. I was interested in scaling up. This is the same hood. I put in a glass peptide reactor. Towards the bottom of that, you see a blue ring holding it up. There's a solid filter in there. So once the derivatized resin is added in there, each reagent can be added with overhead stirring for reactivity. And then towards the right, you can see a nitrogen line that would then push the side products out into the bottom drain into waste. So here, the top left image is just a commercial example off Google of another automated system, another vendor's product. But you can see that chemical manufacturing of a drug like this could literally occur on something that's sit on your countertop, just a little bit bigger than your home microwave. And then the reactors that I would do these types of reactions in are here on the right. They're disposable plastic vials. You can see a white disc towards the bottom. Again, that's the solid filter that allows all of this to occur, not allowing those polystyrene beads to pass through. So let's take a look at some of the possibility. There is precedence here for solid phase indole-derived synthesis. The compound here in the top left is an indole derivative with the 5-methoxy on a polystyrene bead. So you can see that additional chemistry is being done, including that additional ring to the right side of the indole molecule. So some of the science you're looking at here could be applied directly to manufacturing of ibogaine. Additionally, below you can see some more derivatization, the actual indole being synthesized again on solid phase. So there is precedence again that could be applied to ibogaine. I also have a couple more slides. You can see, again, a Wang Resin. It's a type of solid peptide resin that's commercially available. In this case, added to indole or derivatized indole at that one position nitrogen in the bottom left here in scheme 1. So there's totally precedence in the type of chemistry involved with ibogaine that's amicable to this type of chemistry. And again, just some other examples here on the right more tryptamine synthesis, again on the solid phase, with both of these having the references above. So my suggestion, and one of the things I'm probably most excited about from the synthetic side, would be to switch or update some of the solution phase chemistry to solid phase synthesis. The advantages are, once it's worked out, it's completely automated. Those systems that I showed you meter quite precisely the delivery of each of the reagents, the delivery of volumes of compounds used for filtering and purifying. They can very precise in the amount of heating. A lot of the systems have inline reaction monitoring, so you can actually have the system watch to make sure that the reaction's done. This helps with two things. Number one, you can make sure the reaction's done to completion, so that you have less side products and you get your highest yields. And secondly, once you know the reaction's done, you can move on to the next step. So it can actually speed up the process, allowing the drug manufacturing process to be done most efficiently. Some of the systems, I think the second one I showed you, have microwaves built into them to accelerate the chemical manufacturing process. And then what's really exciting is that the process is completely transferable. Each of these, each of the manufacturing processes are essentially a small file that can be emailed to another owner of a system to reproduce it. So this is an area I think that probably, in my opinion, maybe is the hottest area to look into commercialization and decentralization and manufacturing of Ibogaine. So that would be my presentation.
Okay, thank you, Justin. Yeah, sure. We have some questions, Justin. Is that okay?
Sure.
Justin, can we economically produce completely synthetic Ibogaine from scratch, just starting out with some indole ring, basic serotonin or something?
A relative term, but
in a way that will, let me finish, in a way that will free us from dependence on the rainforest.
Sure. I mean, that's certainly on the 18MC side, something I've been involved with for years now. So I have no doubt that it can economically be done. And I would suggest that most of that technology could be converted over to Ibogaine without any issues. Generally speaking, chemistry is economy of scale. It takes the same amount of labor to produce 10 grams of a compound as it typically does 10 kilos. And the reagents are generally not the most expensive. It's usually labor. So yeah, I would suggest that it's probably quite economical to do large scale synthesis from scratch.
What would be the ultimate cost of a gram of Ibogaine to produce it then?
Yeah, again, it's economy of scale. Indoles.
If we were making kilos.
I think that all of these things could be automated. I can't tell you off the top of my head. I haven't certainly costed out, nor do I think anyone's optimized the process for pharmaceutical production, which would give you that exact answer. But you know, this type of stuff's done in industry with other compounds, you know, for decades, if not longer.
Anybody else have a question?
All right, thanks so much.
Hi, Justin. Referring to Dinah's last question, similar situations that were scaled up in the past and probably became very cheap kilo per kilo, you know. How would you say that similar, you know, situations in the past reached below 100, you know, euros or dollars a kilo or a gram or whatever, you know? what information do you have regarding situations like that? Not ibogaine, but other fully synthesized compounds. You know.
Yeah, I mean, I've just in my experience. I mean, we've worked on multi-step synthesis that, on scale, we've gotten down to $1 a gram. Not something quite as complex as ibogaine, certainly, but it's oftentimes the bigger hammer drives things in even deeper. So I just think that, the last time I looked, which has been quite a few years, indol's about $35 a kilogram. I mean, it does not get any cheaper for starting material. Granted, ibogaine's a long synthesis and quite complex, but my expectation is that, with my background in the manufacturing industry, is that when you approach a laboratory and say, hey, I've got this massive synthesis, that slide that I showed that had just tons of chemical structures, chemists look at this and go, oh my God, this is too expensive. This is massive labor. This is massive loss. But what I would suggest is if you tell one manufacturer, hey, I need compound 38 and I need 20 kilos of it, they'll say, oh, that's 5 steps. That's no problem. Like something I'd love to do. And you go to another manufacturer and say, well, I need compound 30. That's 3 or 4 or 5 steps. Oh, absolutely no problem. Great price, high volume. And so I think if you were to piecemeal this together by experts in each process, that would be the correct approach. I've no doubt that trying to get everything done by one place is not the way to go. But I have no doubt that this can be done extremely economical and again, reproducible, and high quality and high yielding.
I just want to note, we have something like 12 million opiate addicts worldwide, and we have about 25 million methamphetamine addicts worldwide. So having something that starts out at $35 a kilo, and you have to, go through a few steps, means that we could actually bring ibogaine to the world.
Yeah, this is the type of business and effort it's done all day. Tries to come to the market all the time.
Thank you very much, Justin.
Yeah, thank you very much. All right, thanks.
saw you last year. Oh. Cousin Simon.